So the next question, we have question number 5. Okay, so we're asked here, draw the graph of the trig functions y equals sine squared x and y equals sine cubed x. So the junior tutor has the following answer, and then we'll go through how to get about the correct answer. So we have these two functions. The trig functions are the periodic functions with a period of and the period of sine x is 2 pi. So for sine x, we know that the period, so we'll say period is 2 pi. Period represented by t. The value of sine x is equal to 0 when x is equal to plus or minus n times pi. So we can see at 0, so when n is equal to 0, we have, when x is equal to 0, we have 0, and then when we have n, so 1, we have at pi, so 3.14 over here, x will also be 0, and so on. So sine x, will also be 0, and so on. As we know, the value of sine x lies between -1 and +1. So for sine x, we know that's between -1 and +1. Here, sine squared x is greater or equal to sine cubed x for this interval, in the interval when sine x is positive. And then they plot the two graphs. So one way to plot these two functions is to kind of just substitute for, let's say, 1, 2, 3, 4, and so on, and kind of just draw dots. You can also cut it down even further. This is kind of the simplest way to go about drawing the graphs. You can also kind of plot it using a graphing kind of calculator, or so as they did here, they kind of just use an online website to graph them. So we'll try to explain what does sine squared x and sine cubed x look like. So sine squared x, so we know for this the period is also 2 pi. So based on this plot, we'll look at this plot. So we have the from 0 to 2 pi. Actually, if we have here to, so 0, so actually let me double check something over here. Okay, so actually it would be actually just pi. I was thinking of something else. So here we can see from the plot, because from 0 to 3.14, this section of sine squared x is repeating over and over, so we know this is the period. And then for sine cubed x, we can see from the plot between pi and negative pi, so we have 2 pi, so pi over here and negative pi, so we have 2 pi for the period. So let me just double check that again. Yep. So we have here that these are the periods, and then we can see that here we're claiming that sine squared x is greater than or equal to sine cubed x. So based on this graph, but if we were asked if sine squared x is greater, like, is this statement true? Like, if we're asked, is this statement true? To know if it's true, we could just plug in a value that's over here. So if we know that the period is pi, we can plug in pi divided by 3. We know at this point these two graphs are equal, but at this point they're not. So if we look at the third, so at this point it is about pi over 3. So if we said sine squared at pi over 3, and we had sine cubed at pi over 3, We know for sine squared pi over 3, if you plug this into your calculator, you get 0.75, and then for sine cubed pi over 3, you get 0.64. So this is just kind of just plugging in values. You can see that sine squared is greater than sine cubed. And then by using a graphing calculator or some kind of graphing software, we can see visibly what this looks like. So in a situation you usually would not be asked to draw it completely. You kind of just have to infer these like plug in a couple of values, and you'll get the sense, because it's a sine function, it's repeating, so you can think about what the period is and repeat it based on that. And you can also plug in values as such to know which function is greater or less than. So we're gonna mark this question as correct. So correct answer. Great job.